In the beginning, there was nothing familiar. No blue planet, no oceans, no mountains, no sky. There was only darkness, and inside that darkness drifted a giant cloud of cold gas and dust. It stretched across space like a silent ghost, thousands of times bigger than our entire solar system today. This cloud, known to scientists as a molecular cloud or nebula, floated quietly for millions of years. It carried the raw materials of future planets, but at this stage, it was just a massive shadow in the void. The narrator explains that this place was not peaceful. It was fragile, unstable, waiting for a spark. And then the universe delivered that spark in the most dramatic way possible. Far away, a massive star reached the end of its life. This star was many times bigger than our sun will ever be. For millions of years, it burned bright, but now its fuel was gone. With nothing left to support itself, the star collapsed under its own weight. Within seconds, the core crushed inward, and then a violent explosion tore through space. A supernova. The blast was so powerful that it could be seen across the galaxy. It released more energy in a few seconds than our sun will release in its entire lifetime. Shockwaves raced outward at incredible speeds. They traveled for light years until finally, they slammed into the quiet, drifting nebula. This was the moment that changed everything. The shockwave compressed the giant cloud, forcing it to collapse inward. Gravity took control, pulling the gas and dust into a spinning motion. Slowly at first, then faster and faster. What was once a lazy cloud now became a swirling disk of matter, like water spiraling into a drain. This disk would soon become the birthplace of something extraordinary. As the narrator describes the scene, the documentary camera dives through the disk. Huge chunks of rock crash and fracture. Gas swirls in bright blue streams. Radiation flashes like storms. Temperature rises sharply as the disk tightens around its center, and deep inside that center, hidden at the heart of the chaos, was a tiny spark of light beginning to grow. This light would become the sun, but at this early stage it was nothing more than a glowing ball of hot plasma, slowly increasing in brightness. Gravity made it denser. Heat made it brighter. Nuclear fusion had not started yet, but the star was waking up. Around it, the newborn solar system was a war zone. The narrator explains that this was not a calm formation. It was violent, unpredictable, and filled with danger. Thousands of solid objects, some as small as grains of dust, others as large as mountains, collided non-stop. Each collision released intense heat, melting and breaking the material again and again. This chaotic stage had only one rule: survive the collisions or be destroyed forever. The documentary visuals zoom into the swirling disk. Viewers see how dust sticks to dust, forming tiny clumps. These clumps grow into larger rocks. Rocks merge into boulders. Boulders merge into blocks. Soon, hundreds of growing bodies begin orbiting the young sun, like newborn children learning to find their place. These early objects are called planetesimals, and they are the seeds of worlds. But not all will survive. Some smash into each other so violently that they break apart into powder. Others are pushed inward toward the sun and vaporize completely. Many drift into unstable orbits and are thrown out of the solar system forever. The narrator's voice deepens as the camera pans across the glowing disk. It was a time of creation, but also a time of destruction. The young sun, too, was changing. The center heated up more and more. Fusion finally ignited. Hydrogen atoms began merging into helium, releasing massive energy. The sun lit up like a cosmic furnace, sending waves of heat and solar wind through the disk. The solar wind blew away lighter gases from the inner region of the disk, creating the first boundary lines of the solar system. Planets forming close to the sun would become rocky. Planets forming far away would grow into giants of gas and ice. The narrator describes this as the first major separation between planetary types. But at this point in the story, Earth did not exist yet. Not even a hint. Only dust, fire, and countless collisions. As the millions of years passed, small planetesimals continued to merge. Slowly, larger bodies formed. Some grew to the size of moons. A few became the size of small planets. One of these growing bodies was located in a region roughly 150 million kilometers from the sun, what would one day be Earth's orbit. But this early object, the proto-Earth, was still tiny, unstable, and vulnerable. A single large collision could erase it instantly, and that threat was very real. The narrator shifts the camera's attention to another forming planet, Jupiter. Jupiter was growing at a terrifying speed, became massive, so massive that its gravity changed everything around it. This giant planet was like a bully on the cosmic playground, pulling and pushing everything in its path. Whenever smaller bodies came close, Jupiter's gravity slingshot them across the solar system or sent them crashing into other worlds. Its influence was so powerful that many early planets never stood a chance. They were shattered or thrown away. The narrator explains that without Jupiter's chaotic behavior, our solar system could have been a very different place. But for Proto-Earth, this danger also became a strange form of protection. Jupiter's gravity cleared out many dangerous objects that might have destroyed young Earth. At the same time, it also sent new planetesimals raining inward, feeding Earth's growth. It was violence, but necessary violence. As the narrator builds suspense, viewers watch intense visual sequences of impacts. Massive rock the size of a mountain crashes into Proto-Earth, melting large parts of its crust. The world grows larger. Slowly, very slowly, it becomes one of the surviving planet-sized bodies in this inner region of the solar system. But survival was still not guaranteed. The sun was still unstable. Solar flares blasted plasma waves across space. Radiation storms heated and cooled the disk. Cosmic debris constantly rained down, turning every day into a disaster. Then the narrator asks the first suspenseful question of the documentary: how did Earth in all this chaos become a stable and perfect home for life? This question hangs in the air, inviting the audience deeper into the story. The camera now zooms out, showing the entire solar system as it looked 6 billion years ago. Rings of dust swirl like glowing halos. Clumps of molten rock drift through space. Prototype planets glow with heat. It is a newborn cosmic family, wild and unpredictable. The sun shines brighter now. Its magnetic field stabilizes. Its solar wind sweeps the remaining gas away. Slowly, the disk begins to clear. What remains are giant planets far out, rocky planets forming inside, and countless smaller bodies still roaming freely. Among these bodies is one that will play a huge role in Earth's future, but viewers don't know that yet. The narrator only hints at it. Another world, not far from the Proto-Earth, was growing at the same time, and soon their paths would collide in a moment that would change everything. This sets up the dramatic entrance of the object known as Theia, but that will come in the next part. The documentary returns to the Proto-Earth, now a glowing sphere of molten rock. Volcanoes erupt constantly. Rivers of liquid fire flow across the surface. The young planet rotates quickly, completing a day in just a few hours. There is no atmosphere, no water, and no sign of life. Only endless heat and destruction. Yet the narrator emphasizes that this violent stage was essential. Without this molten period, Earth would not have separated into layers: core, mantle, crust. Without these layers, Earth would not have a magnetic field. Without a magnetic field, Earth would not be protected from the sun's deadly radiation. And without protection, life could never survive. Every moment of chaos had a purpose. The narrator concludes part 1 with a final sweeping shot of the Proto-Earth surrounded by debris, glowing under the young sun. The camera slowly pulls back into the dark background of space. The final line creates a suspenseful cliffhanger, but Earth's greatest test, the event that would shape its destiny forever, was still ahead. A collision so powerful that it would remake both worlds and give birth to a new companion in the sky. The screen fades in from darkness. A deep, distant rumble echoes through the void as the narrator returns, his voice calm but heavy with meaning. 4.5 billion years ago, the early solar system had finally begun to take shape. The sun burned brightly at its center, clearing the remaining gas with powerful winds. But the space around it was still far from peaceful. It was a place of unfinished worlds, violent collisions, and endless transformation. A slow cinematic sweep reveals the newborn solar system from above. Instead of the calm, organized structure we know today, the planets are still forming. Dust clouds drift between orbits. Asteroids and giant boulders cross paths unpredictably. The camera moves closer and the narrator describes the scene in simple, clear words. This was the age of building. The age where planets were not yet planets, only possibilities. All around the sun, a vast disk of debris spins like a cosmic construction zone. Some regions glow from heat, others remain dark and cold. In the inner zone, where the temperature is high, only solid minerals survive. This is the birthplace of rocky planets: Mercury, Venus, Earth, and Mars. In the outer zone, where sunlight barely reaches, large icy bodies are forming, mixing with hydrogen and helium to become the giant planets. But among all these young worlds, one object, small, unstable, and still growing, stands out: the Proto-Earth. At this stage, Proto-Earth is nothing like the world viewers know. It is smaller, rougher, and constantly attacked by incoming rocks. Every few seconds, somewhere on its surface, an impact creates a huge explosion of molten material. The narrator describes it like an endless meteor storm. Imagine a world where the sky is always glowing with fire, where the ground is never cool, where mountains rise in seconds, only to collapse minutes later. The camera zooms in to show giant impacts from massive planetesimals. Each impact reshapes the landscape. Cracks stretch for hundreds of miles. Rivers of lava spill into deep basins. Clouds of boiling vapor rise into the air. It is a world trying desperately to build itself while constantly being torn apart, yet there is progress. The proto-Earth grows larger and heavier. With every new collision, it gains more mass, and with more mass comes more gravity. This gravity allows it to attract even more material, accelerating its growth. The narrator explains, planet formation is not a peaceful process. It is a competition, a race. Only the largest objects survive long enough to become planets. Around proto-Earth, smaller planetesimals orbit nervously, constantly at risk of being pulled in or flung out. Some crash into the surface with such force that they melt instantly. Others bounce off and shatter. The building of a planet is messy, but it is also fascinating. Now the camera drifts outward and focuses on a new character in the story, Jupiter. Jupiter is enormous even in its early stages. Gas swirls into its forming atmosphere like giant storms. Lightning flashes beneath thick clouds. It is already the king of the solar system. Its gravity is so powerful that it acts like a cosmic gatekeeper. The narrator explains in simple words, Jupiter grew faster than any other world, and because of its size, it controlled everything around it. Nothing could ignore its gravity. Jupiter's presence dramatically shapes the solar system. Many early planets that were forming near it are torn apart. Some are thrown inward, becoming deadly projectiles that enter the inner solar system. Others are pushed outward and lost forever. It is a gravitational dance and a gravitational massacre. The documentary shows massive objects flying at incredible speeds. Some crash into proto-Earth, helping it grow. Others miss by narrow margins. The solar system begins to look like a battlefield filled with broken worlds, but even this destruction plays an important role. Without Jupiter, the narrator says, Earth might never have existed. Jupiter removed many giant threats, but at the same time, it also sent new material inward, feeding the growth of Earth and the other inner planets. The early inner solar system becomes more organized. 4 rocky planets begin to separate into distinct orbits. Mercury forms closest to the Sun, but its surface is constantly blasted by solar radiation. Venus forms a little farther out, growing rapidly into a massive hot planet. Mars forms farther away, but it remains small and fragile. And in the middle, proto-Earth continues its long, violent journey toward becoming a real planet. Now the documentary shifts focus to the Sun, a young star burning hotter than ever before. It emits powerful solar winds that push away leftover gas. This begins the great clearing of the inner solar system. The narrator describes it as a storm that sweeps the cosmic construction zone clean. Anything too light was blown away forever. Anything too small was removed from orbit. What remained were the strongest survivors, the planets that would shape the future of our solar system. Proto-Earth is one of these survivors. With fewer small objects around, the collisions become less frequent but much more significant. The objects that remain are larger, moon-sized or bigger. Any collision now is catastrophic. The camera shows one such event. A giant body slams into proto-Earth, releasing more energy than millions of nuclear bombs. Surface melts into a glowing ocean of fire. But the narrator reminds the viewer, these impacts were not accidents. They were nature's way of shaping a planet. Because of such collisions, proto-Earth begins to differentiate internally. Heavy metals sink to the center, forming a metallic core. This core will one day create Earth's magnetic field, a shield that protects life. Lighter materials rise to form a mantle and early crust. The planet becomes layered, complex, organized, and stable on the inside. Now the narrator transitions to a more suspenseful tone, but something else was happening in the early solar system, something that no one could see at first. Another young planet was growing near proto-Earth, and their paths were slowly moving closer and closer. The documentary camera reveals a second world forming only a short distance away. This planet is called Theia. Slightly smaller than Earth, Theia is also collecting material, also fighting for survival, also trying to become a full-size planet. The narrator speaks softly. At first, Theia and proto-Earth shared their space peacefully, but gravity does not allow peace for long. Their orbits began to shift, slowly, dangerously. Theia becomes one of the greatest threats proto-Earth will ever face, but that story belongs to the next part. Before ending part 2, the documentary focuses again on the larger picture of the solar system. Millions of years pass in seconds. Dust clears, orbits stabilize, the sun glows far brighter. Giant planets settle into their long-term positions. The inner planets continue to grow, and the narrator summarizes, the solar system was no longer a swirling cloud of dust. It was becoming a family of worlds. Each planet had its own path, its own structure, its own destiny. And at the center of this transformation stood the proto-Earth, now nearly complete, waiting for the moment that would define its future. The final cinematic shot shows proto-Earth and Theia slowly drifting toward one another, like two worlds drawn by fate. Then the narrator delivers the final suspense line for part 2. Two young planets were about to collide. The impact would be so powerful that it would reshape Earth, create the moon, and set the stage for life itself. Darkness fades into a fiery red glow. The camera slowly descends onto the young proto-Earth, a world that looks nothing like the calm blue planet viewers know today. Its entire surface is molten, swirling with bright orange rivers of lava. Huge plumes of vapor rise into space like boiling smoke. The narrator begins in a low, cinematic voice. 4.5 billion years ago, Earth was not a home. It was a nightmare, a place of endless fire and constant destruction. The proto-Earth rotates quickly, completing a full spin in just a few hours. With each rotation, new scars form. Explosions flash everywhere as giant rocks crash down from the sky. Every impact shakes the crust, melts new regions, and mixes the planet's materials like a cosmic blender. This was the final stage of Earth's creation, the narrator explains. A stage where only the strongest worlds could survive. The documentary zooms in on a city-sized asteroid hurtling toward proto-Earth, strikes with unimaginable force, releasing energy greater than millions of modern nuclear weapons. A huge crater forms instantly, spewing molten rock into space. The glowing ejecta briefly forms a fiery ring before falling back again. To the audience, every collision looks deadly. But the narrator reminds them, these violent impacts were necessary. Without them, Earth would not have formed its iron core, its layered structure, or the magnetic field that protects life today. The scene cuts to a cross-sectional view of the planet. Viewers see how heavy iron sinks toward the center, forming a growing metallic core. Around it, molten rock churns slowly, creating deep currents. This separation of materials, the narrator says, was the beginning of Earth becoming a complex world, not just a ball of rock. But the calm does not last long. Far away, another planet-sized body comes into view. Slightly smaller than Earth. Covered in molten rock and dust, this object moves silently through space. This is Theia. The narrator takes a careful pause, allowing viewers to absorb the tension. Theia was a young world born from the same cloud of dust as Earth. For millions of years, it shared Earth's orbit peacefully. But gravity is unpredictable. Their paths drifted closer until collision became inevitable. A dramatic visual shows both proto-Earth and Theia orbiting the Sun, gradually approaching each other. Spirals of dust follow their paths, creating a hypnotic dance. The narrator continues. For a brief moment, the two worlds moved in harmony, but their peaceful dance was coming to an end. The forces of gravity were pulling them toward the most important impact in the history of the solar system. The music intensifies. The planets drift closer. Viewers can sense the approaching chaos. Then, silence. Theia suddenly fills the entire screen. Its shadow stretches across proto-Earth's surface. The narrator whispers, then it happened. A deafening explosion blasts across the frame. Theia slams into proto-Earth at an angle like a cosmic hammer striking a molten shield. The collision is catastrophic. Shockwaves ripple through both planets. The surfaces of both worlds melt instantly. Oceans of lava rise and explode into space. The impact is shown in slow motion. Mountains crumble. The crust breaks apart. Fire spreads in enormous curtains. Even space seems to tremble. The narrator describes this event with controlled intensity. Theia did not just hit Earth. It fused with Earth. The impact melted both worlds and tore away a massive amount of material. The force of the collision is so great that billions of tons of vaporized rock are ejected into orbit. Streams of molten material form a glowing arc around the planet, slowly spreading into a ring of debris. This ring would not remain a ring for long, the narrator explains. It was the beginning of something new. As the molten fragments cool, they start to clump together. Gravity pulls them into larger pieces. Over thousands of years, these pieces merge into a single massive object, the Moon. The documentary now shifts to the formation of the Moon, showing it as a glowing, molten sphere floating above the devastated Earth. Volcanoes erupt across its surface. Large craters form as leftover debris continues to strike. The Moon was born from destruction, the narrator says, but its presence would become one of Earth's greatest gifts. Meanwhile, proto-Earth, now fused with most of Theia's material, begins to stabilize. The planet is much larger than before. Its core has grown stronger, its rotation has changed, and its tilt has become more pronounced. The narrator explains, the collision changed Earth's future. It gave Earth the Moon. It changed Earth's tilt, which would later create seasons, and it helped Earth build a magnetic field strong enough to protect life. The camera shows the young Earth glowing with magma. Every inch is covered in molten rock. The atmosphere is full of vaporized minerals and superheated gas. This is a world reborn, not yet safe, but full of potential. But the violent birth of Earth is not over. Even after the Theia impact, Countless smaller collisions continue for millions of years. The documentary shows asteroids and comets striking the planet, adding new minerals, water, and chemicals. The narrator explains why this bombardment mattered. Each impact brought something new: metals, gases, water-bearing minerals, and important chemical elements. These ingredients would later help Earth become a living planet. In one sequence, a massive asteroid containing carbon-rich compounds crashes into Earth. The narrator describes this moment. These carbon molecules were essential for life. Without them, the earliest forms of biology might never have appeared. Another sequence shows icy comets streaking across the sky, their bright tails glowing. Comets carried water ice, the narrator explains. When they crashed, they released this water onto Earth's surface. Though Earth still had no oceans, the seeds for future water were now in place. The scene transitions to the young moon orbiting closer to Earth than it does today. The moon appears huge in the sky, dominating the horizon. Its gravity creates massive tides in the molten oceans of magma below. The moon did more than shine in Earth's sky, the narrator says. It stabilized Earth. Without the moon, Earth would wobble wildly. Seasons would be chaotic. Life would struggle to survive. This creates a deep emotional moment. Viewers see how something born from destruction would eventually become a guiding stabilizer for Earth. Now the documentary zooms out, giving a cinematic view of Earth and the moon together for the first time. The narrator describes the significance. This partnership, Earth and its moon, became the foundation of a stable world. A world that could cool, form oceans, create continents, and eventually host life. However, cooling would take time. A lot of time. The narrator continues. For millions of years after the collision, Earth remained a glowing sphere. Its surface boiled. Its atmosphere was filled with thick, toxic clouds of vapor. Lightning flashed non-stop. Inside Earth, intense heat drove convection currents that churned the mantle. Volcanic activity dominated the landscape. Lava fountains erupted in every direction. It was a world that seemed impossible to live on, the narrator says. But it was also a world preparing itself. Earth cooled, the molten surface slowly began to solidify into the first crust. This crust cracked often and melted repeatedly, but over time it thickened. Earth was taking its first steps toward becoming a solid world. The documentary then returns to the moon. Still molten and cratered, it reflects sunlight in a soft orange glow. Each year the moon moves slightly farther from Earth. Even today, the narrator notes, the moon continues to drift away about 3.8 centimeters every year, a reminder of the ancient event that created it. Now the camera shows Earth from space with the moon orbiting closely. Explosions still mark the planet, but the chaos is slowly decreasing. The narrator offers a powerful summary. Earth had survived its greatest test. Theia's impact nearly destroyed it, but it also completed it. From that collision, Earth gained its size, its core strength, and a moon that would guide its future. At this point, the music softens. A deep blue shade begins to replace the fiery orange. The narrator ends part 3 with a cinematic transition. As the fires began to fade, Earth was finally ready for its next transformation. The world that was once only molten rock would soon become a world of water. The screen fades in from darkness, revealing a world still glowing with heat. The surface of early Earth looks like a sea of fire. Rivers of lava stretch across continents that do not yet exist. The air shimmers with poisonous gases. The narrator begins in a quiet, heavy tone. After the giant collision that created the moon, Earth was reborn. But this new Earth was far from calm. It remained a burning world, violent, unstable, and extremely hot. This is the moment after the chaos, but before the calm. Molten rock still covers most of the planet. The atmosphere is thick with vaporized minerals, carbon dioxide, sulfur gas, methane, and dust. There is no oxygen, no water on the surface, no sign of oceans, but something incredible is about to begin. The camera moves slowly above the molten surface, showing glowing cracks that pulse with heat from deep inside Earth. The narrator continues. Inside Earth, everything was moving. The mantle churned like a boiling ocean. The core spun faster than ever before, generating a strong magnetic field, a shield that would protect the planet from deadly radiation. This magnetic field appears like a glowing blue bubble around Earth, deflecting solar wind and cosmic particles. Without it, the young atmosphere would be stripped away. But thanks to the shield, Earth's future is safe. Now the documentary zooms out, showing the moon orbiting much closer than today. Giant tides rise in the molten rock below, pulled by the moon's gravity. With every orbit, the moon shaped Earth's movement. It slowed Earth's fast rotation. It stabilized Earth's tilt, and it prepared the world for the next great transformation, cooling. Over millions of years, the molten surface begins to change. The outer layer cools slightly and hardens, forming a thin crust. At first, it cracks constantly, broken by volcanic eruptions. but gradually the crust becomes thicker and more stable. The narrator explains in simple words, Earth finally took its first step toward becoming a solid world. The fires were slowing. The surface was trying to cool. As the crust expands, volcanoes release massive amounts of gas into the air. This process, called outgassing, creates the first stable atmosphere. The sky fills with steam, carbon dioxide, nitrogen, ammonia, and sulfur compounds. The air is thick, dark, and toxic. But the narrator reveals why this matters. This early atmosphere was the beginning of everything. It was Earth's first breath. Now the camera focuses on the sky. Giant clouds form as steam rises endlessly from the still hot surface. Lightning flashes again and again, illuminating the dark sky. Thunder rolls across the empty world. The narrator describes the moment. For the first time, Earth had weather. The sky was alive. And then something historic occurs. Droplets form. The first rainfall in Earth's history begins to fall from the sky. At first, the droplets turn to vapor before hitting the ground. Earth is still too hot. But as millions of years pass, the surface cools further. Rain stays liquid a little longer, then longer, then longer, until finally, rain touches the ground. The documentary shows the first raindrops landing on hot rocks, creating small bursts of steam. It is a breathtaking moment. The narrator speaks softly. Water had arrived. And with water, everything began to change. Rain falls harder and harder. What begins as droplets become storms. Then storms become floods. For thousands of years, rain falls without stopping. The world endures a torrential downpour that shapes continents and fills basins. This is known as the Great Rainfall, a period when Earth cooled enough to allow water to accumulate on the surface. Massive rivers form. Lakes appear. Early oceans begin filling the low areas on the crust. The camera shows Earth slowly turning blue for the first time. Billions of tons of water crashed down from the sky, the narrator explains. But this was not the only source of water. Space brought water too. Now a new sequence begins. Comets streak through the sky, bright blue tails glowing against the dark atmosphere. These icy visitors crash into Earth, releasing their water content upon impact. Comets were frozen containers of water and organic molecules, the narrator says. When they struck Earth, they delivered precious ingredients that would later help life begin. Asteroids also bombard the planet. Many carry carbon compounds, minerals, and chemical elements essential for biology. Even though these impacts look destructive, they are delivering the resources that will make Earth special. The camera zooms into one drop of water, showing tiny dissolved minerals and carbon molecules swirling inside. Inside these early oceans, the narrator continues, simple ingredients mixed together, molecules clashed, separated, and reformed. Lightning provided energy, heat from volcanic vents gave power, chemical reactions began to change the water. This moment is the dawn of chemistry, complex molecules forming naturally in the ocean. Now, the documentary dives deep into the early oceans. The water is dark, thick, and full of dissolved metals and gases. At the bottom of these oceans, incredible structures rise, hydrothermal vents. These vents release hot, mineral-rich water from inside Earth. The mixture creates a surreal environment of shimmering heat waves and towering mineral chimneys. These vents were natural laboratories, the narrator says. They mixed heat, minerals, and water. They created the perfect conditions for chemistry to evolve into something more. Complex molecules like amino acids begin forming. These molecules join together into chains. The chains fold into shapes. Some shapes begin to react with their surroundings in unusual ways. The narrator adds suspense. One day, something remarkable happened. A collection of molecules formed a pattern that could copy itself. This is the birth of self-replicating chemistry, the foundation of life. But the documentary does not yet call it life. Instead, it builds tension. The oceans were changing. Something new was forming in the darkness, something that would one day become alive. Now we return to Earth's surface. The planet is no longer glowing red. It has cooled enough for continents to begin forming. Landmasses rise slowly from the ocean as volcanic rock hardens. The sky is still filled with carbon dioxide and steam, but it becomes clearer as temperatures drop. The narrator paints a vivid picture. Imagine looking at Earth during this time. The sky is orange. The oceans are dark green. Volcanoes erupt across every horizon. There's no blue sky, no green forests, no animals, only a young world trying to stabilize. Even though the world is harsh, it is filled with potential. Earth's rotation slows thanks to the moon's pull. Days stretch from 6 hours to 10 hours to 15 hours. Weather becomes less extreme. The atmosphere thickens, creating greenhouse effects that keep the planet warm. Earth is becoming a planet ready for life. The narrator shifts the tone to hopeful. With water on the surface, a stable crust, and a protective magnetic field, Earth had everything it needed for the greatest transformation in the history of the universe, the rise of life. The camera zooms deep into the ocean again. Tiny bubbles rise from the vents, molecules interact. A small cluster of simple structures begins to form a membrane, a protective skin. This membrane allowed chemistry to stay in one place, the narrator explains. A container for reactions, a place where patterns could grow. This is the first protocell, a simple bubble of organic molecules, not alive yet but close. The narrator whispers, and inside one of these bubbles, the first spark of life was waiting to be born. Now the camera zooms out, showing Earth from space. Deep blue oceans cover most of the surface. Volcanic islands dot the landscape. Thick clouds drift in slow spirals. Earth was no longer a burning world, the narrator says. It was now a world of water, storms, and chemistry, a world ready for the next chapter. The music rises softly. The oceans carried the building blocks. The atmosphere protected them. Energy pushed them to change. Earth was preparing to create something completely new. The final shot of Part 4 shows sunlight breaking through thick clouds and touching the ocean for the first time. The narrator ends with a cliffhanger. Something was coming. Something small but powerful enough to change the future of the entire planet. The screen opens on a dark, underwater world. No sunlight reaches this place. The only light comes from glowing minerals near the hydrothermal vents on the ocean floor. The water here is warm, rich with chemicals, and alive with energy. The narrator speaks softly. In the deep oceans of early Earth, far away from storms and lightning, small reactions were happening. Reactions that would soon change everything. The camera focuses on tiny clusters of organic molecules floating in the water. Carbon compounds twist and fold. Chains of molecules link together. Membranes start to form around them, creating small bubbles. These bubbles were simple, so simple that they were not alive, but they were different from everything else around them. They held reactions inside. They protected patterns. They allowed chemistry to slowly learn. Millions of these tiny structures form and break apart. Most disappear quickly, but a few survive long enough to grow. A few learn to copy their own patterns. This is the beginning of biological evolution. The narrator explains in simple terms. This was the moment when Earth stopped being only a planet and started being a cradle for life. Now the documentary zooms out of the dark ocean into shallow waters closer to the surface. Here, sunlight finally reaches the waves. The water glows in soft blue and green shades. Minerals swirl in the warm currents. Sunlight and chemistry work together in these shallow seas. The narrator says, the ocean was like a giant laboratory. Tiny protocells drift in the warm water. Some absorb energy from sunlight, some use heat. Others react to minerals around them. With each small improvement, they survive a little longer. Slowly, very slowly, they become more stable. Then one protocell develops a new ability, self-replication. It found a way to make copies of itself, the narrator says. This simple ability changed the history of Earth forever. The first living cell, primitive and simple, appears in the ocean. It has no brain, no senses, and no organs. It is nothing like the animals or plants viewers know, but it has two powerful abilities. It can copy itself. It can evolve. The narrator speaks calmly. This was life's first step. A small step, but the most important one in Earth's entire history. Now the documentary shows millions of these simple cells multiplying across the ocean. They spread into every corner, deep vents, surface waters, shallow pools, and volcanic shores. Earth is still young and unstable. Volcanoes erupt often. The atmosphere is thick with carbon dioxide and nitrogen. There is no oxygen to breathe. But these early cells don't need oxygen. They use chemicals from the environment to survive. The earliest life forms were simple, the narrator says, but they were clever. They adapted to whatever the planet gave them. Slowly, life begins to change the planet. The documentary shifts to the surface. Early Earth looks different now. The crust has cooled. Land masses rise from the ocean. Volcanoes form long chains. Thick clouds drift above. Lightning flashes less often and the climate becomes more stable. Earth was growing older, the narrator explains. And as Earth changed, life changed with it. The camera zooms into shallow coastal waters, where a new kind of cell begins to appear, one that can use sunlight. This cell contains tiny structures that capture light and convert it into energy. This was the birth of photosynthesis, the narrator says. Life started making its own food using light. These new cells release a byproduct, oxygen. At first, the oxygen reacts with chemicals in the ocean. Iron in the water rusts, settling on the ocean floor and forming huge iron deposits. The oxygen disappears quickly, but life continues producing more. Slowly, oxygen began to fill the ocean, the narrator says, and then it began to rise into the sky. The atmosphere starts changing for the first time in millions of years. Carbon dioxide levels drop, oxygen levels rise. The sky becomes lighter, clearer, less toxic. The narrator adds, this change did not happen in days or years. It took millions of years, but step by step, Earth's air was transforming. Now the documentary shows a dramatic time-lapse of the planet. Clouds swirl, continents move slowly, oceans deepen, the moon drifts farther away. Earth's rotation slows even more, giving the planet longer days. Earth was becoming stable, predictable, suitable for life. Life responds to this stability by evolving new forms. Cells become more complex. Some join together, forming colonies. Others form partnerships. The diversity of life increases dramatically. The narrator continues. Life learned new ways to survive. Some used sunlight, some used heat, some used chemicals, but all of them grew. The documentary shows simple algae covering the shallow ocean. Early microbial mats spread across rocky coastlines. These organisms release more oxygen every day. Over time, the narrator says, life changed the entire atmosphere. The sky becomes blue for the first time. Sunlight reaches the surface more clearly. The oceans take on their familiar deep color. This was the world Earth was always meant to become. The narrator says, a planet with air, with water, and with growing life. Now the camera zooms out into space, showing Earth from above. For the first time in the documentary, the planet looks recognizable: blue oceans, scattered land, and a bright atmosphere surrounding it. But the narrator reminds viewers, this stable Earth did not happen by accident. Everything that came before, every collision, every eruption, every storm, prepared the planet for this moment. The moon shines softly above Earth. Its orbit is wider now, but its presence still stabilizes the planet. The moon kept Earth steady, the narrator says. It balanced Earth's spin. It shaped the tides. It protected the early oceans from chaos. These regular tides helped mix nutrients in the water. They brought life closer to the shore, where evolution accelerated. Without the moon, life may have remained trapped in a narrow range of environments. Now the documentary shifts to the deep ocean again. Complex cells appear, cells with internal structures, protective membranes, and advanced chemistry. These cells were the ancestors of every plant, every animal, and every human, the narrator says. From simple beginnings came endless possibilities. The visuals take the audience on a journey through time. The narrator describes how life slowly grows more complex, but the story remains focused on the early world, not the future. Earth was no longer a molten world, no longer a storm of fire and destruction. It had become a world of stability, a home. The camera returns to the surface. Volcanic islands cool and split. Early continents form slowly, drifting apart. Mountain ranges rise and crumble. Oceans deepen and circulate with currents. Weather becomes more regular. Rain, sunlight, climate, and oceans work together to shape Earth into a balanced system. The narrator says, this balance allowed life to grow. The narrator pauses and the music softens. Earth did not start perfect. It became perfect through time, through chaos, and through change. The final visuals show Earth rotating slowly, sunlight reflecting off the oceans. The moon hovers above, watching over its partner. The narrator ends the documentary with a powerful final message: from dust to fire, from fire to water, and from water to life, Earth's 4.6 billion-year journey is a story of survival. A reminder that every breath we take, every ocean wave, every sunrise is the result of ancient cosmic events that shaped our world. Earth was not simply born, it was forged.